All right, so in this video, I'm going to go a little over some harder examples of rational functions going through the process to find everything. The first one I'm going to go ahead and do is f of x equals 4 over x minus 3. In my last video, I talked about why it looks the way it does and plugged in specific values. I'm going to skip over that and just kind of go to the shortcuts here. I know that the first thing is I can't divide by 0. So I look at the denominator and I ask myself, okay, what would make the denominator equal 0? This one's pretty simple. 3 minus 3 is 0. But remember, I can't divide by 3. I can't divide by 0. So x can't be 3. So what I'm doing, I'm drawing a vertical line here, and I'm drawing a dashed line. This line is not part of my function. This is a gap in my function. This is that vertical asymptote. So if you're taking notes, vertical asymptote means your denominator was equal to 0. There's a little nuance, we'll talk about that later. Then I think about horizontal asymptote. That's when I plug in really big numbers for x, like 1,000,000 or 1,000,000,000. If I plugged in 1,000,000, I would have 4 over practically 1,000,000. And if I plugged in 1,000,000,000, I'd have 4 over just under 1,000,000,000. And when I take the number 4 and I divide it into millions of parts or billions of parts, I get really, 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 really small numbers. So I know that as x gets really big, my function gets really small. My horizontal asymptote is right here at y equals 0. The same logic works when x goes to positive infinity or to negative infinity. If I do 4 divided by a negative million, I still get a really small number. So those are my asymptotes. Again, those are not the actual function. Those are just the gaps where my function is not. Okay? Then I think about where is my function positive and where is my function negative. If I plug in numbers that are bigger than 3, like anything bigger than 3, like x equals 5 or x equals 10. If I plug in 5, just as an example, I get a positive number because 5 minus 3 is positive. It's 2. So I know that when I go to x equals 5, I'm going to be at y equals 2. F of 5 is 2. If I went on the other side of negative 3, like for example, if I plugged in 0, I'd get 4 over 0 minus 3. That's negative 4/3. That's like negative 1 1/3. So that's a point right there. So now I can see that the only way I can have my function work here is if it goes through kind of quadrant 1 and quadrant 3, like that. So let's see how I did. I found the y-intercept, I found the asymptotes, and I just kind of curved it through everything else. Okay, pretty darn good. Obviously, I didn't get the curvature exactly correct. That's okay. All right, we're going to do one more example that's just a little bit harder. So let's take a slightly harder function, something like this. G of x equals 4x minus 1 over 2x plus 5. Okay? Well, I'm going to start like I did before. I'm going to figure out what makes the bottom equal 0 because I can't divide by 0. You've solved many, many, many types of equations that look just like this. Hopefully it's just kind of autopilot. You're getting your numbers on one side, your x's on the other. So negative 2.5 is where I'll put my vertical asymptote. Okay? Then let's think about plugging in really big numbers. If I plug in a number like g of 1,000,000, let's just pretend I got 6 zeros there. That's going to be basically, I'm just going to approximate, it's going to be basically 4 million over 2 million. I mean, really, it's 3,999,999 over 2,000,005. But it's pretty much 4 million over 2 million. 4 million divided by 2 million is 2. And if I plug in a billion, it's practically 4 billion over 2 billion, etc. The -1 and the 5 are negligible. You don't need to worry about them. So the idea here is that as I plug in bigger and bigger numbers, both directions, my function gets closer and closer to 2. Not equals, sorry, g of x approaches 2. That should be an arrow instead of an equal sign. Oops. Okay, so I can go through y equals 2. That's my horizontal asymptote. Y equals 2 like this. Last thing I'm going to do is figure out that y-intercept and see if there are any x-intercepts. So plugging in 0 gives me the y-intercept. You might notice that plugging in 0 just leaves you with the ratio of the constants. So I have -1 over 5. So that's a negative number. And then let's figure out when the equation equals 0. So I don't plug in 0, I write down my equation equals 0. Okay, how do you get rid of a fraction? You multiply both sides by the denominator. Denominators cancel. 0 times anything is anything. Sorry, 0 times anything is 0, no matter what anything is. Add 1 to both sides, so 4x is 1. Divide by 4, and I get a fourth, which is right about here. So we know that this branch, oops, I missed it. This branch of the function hugs the asymptotes like this, and this branch of the function hugs the asymptotes like that. That is an ugly, okay, that is not my most beautiful rational function, but that's okay, we'll survive. When you're typing it into your calculator or to Desmos, just use the parentheses so it gets all the correct stuff on the top and the bottom. And you can see that I was pretty darn close with the graph. Okay, there's sort of one more level up of difficulty that I'll do in another video, but the first video was like the theory of why it looks like this in the first place. This video was more just quicker, getting the graphs done, and I'll do one more video with some harder examples.